Hello, welcome to another video of Taste of Farming. My name is Beth Sastre. I am the commercial horticulturist in Loudoun County, Virginia. Some of you own a piece of land and may be wondering if the location is good to establish a vineyard. Some of you may be looking to purchase land and want to know what factors of the land are the most important to consider to start the vineyard. Today, we will quickly learn about the main factors that determine a suitability for a vineyard. The factors to consider are two: site evaluation and those on 1 year in advance. Site evaluation encompasses macroclimate, mesoclimate, and microclimate. 1 year in advance factors are beginning planning the vineyard layout, choose the varieties, and order the grapes. Why is the site selection important? Because your vineyard profitability and sustainability are dependent upon selecting an excellent site. Site selection is the first and probably most important step in vineyard establishment. Once the vineyard is established, it is nearly impossible to change physical features to improve the vineyard's relative position with surrounding topography and vegetation. Soil chemistry can be altered somehow, but changing soil physical features such as depth or internal drainage is again nearly impossible. If a crop failure occurs during the spring frost or early fall frost, it will reduce the quality of the fruit. The profitability of the enterprise can be severely compromised. At the end of this presentation, we will review a proposed ranking of priorities from high to low that a candidate vineyard site should be evaluated for. High priority features such as relative elevation and internal soil water drainage must not be ignored. Others that are ranked much lower in priority may ultimately be compromised on. Again, as with buying a house or recreational property, no site will be entirely perfect. The key is to understand the ranking of site features. These are the physical features and the level of priority from high to low that a candidate vineyard site should be evaluated for. High priority features such as relative elevation must not be ignored. Others that are ranked much lower in priority might ultimately be compromised on. Again, no site will be entirely perfect. The key is to understand the ranking of site features. Okay, let's summarize the site evaluation process and put the features into an order of importance. One feature that you should never compromise is the microclimate. Relative elevation and absolute elevation are things that you will not be able to change once your vineyard is established. These are geographical features of your site. The prevailing climate of a large geographic area is called macroclimate. Macroclimate is what exists in the grand scheme of things. It is the overall climate of a specific region. Macroclimate of mid-Atlantic region can be, for its larger part, classified as continental, with an exception of the eastern seaboard of the United States, which belongs to the oceanic climate. What is the difference between continental and oceanic climates? In regions with continental climate, the temperature and precipitation patterns are modified by large land masses, while in the oceanic climate, these patterns are modified by a large body of water. Since land rock that has 2 times smaller heat capacity than water, temperature fluctuation on day-to-day basis can be rapid in continental regions. Unlike continental, a close proximity of a huge body of water on regions with the oceanic climate acts as a buffer for a suddenly temperature fluctuation. What this practically means is that during summer, a large body of water absorbs heat, which later, during the colder days in fall, gets slowly released, warming up the air in the area close to the water, and thus extend the growing season and may even raise the mild winter temperature, preventing cold winter damage on the vines. In the spring, this process goes in the opposite direction. Now the large body of water helps cooling the surrounding air, which further retards plant development and reduces the risk of spring frost damage. Therefore, the features of a macroclimate that can help us to determine if a region is suitable for wine grower are length of growing season, growing degree days, frost, frequency of extreme low temperatures, temperatures from July through October, and precipitation. I will closely talk about each one of these on the following slides. Growing season is defined as the period without frost. The beginning of this can be marked with the last spring frost and the end with first fall frost. Why is this important? Because like any other plant, a vine requires a certain period during which it can complete annual growth cycle and produce fully ripened grapes. Generally, 165 days is considered as minimum, and most of the grape varieties will require more days to ripen. Here are some examples of early and late ripening varieties. Muscat and Viognier require 155 days. These are early ripening varieties. Petit Verdot or Nocturne require 108 days or more. These are late ripening varieties. Many areas of the Mid-Atlantic have in excess of 180 days of frost-free growing season, as shown on this map of North Carolina and Virginia. The inset shows a frosted shoot, a consequence of continental climate. Such a spring frost can be dramatically reduce crop and also shortens the growing season for that year. Note that the length of the growing season tends to decrease in the mountainous regions of western North Carolina and Virginia. These areas are also associated with increased elevation and lower winter minimum temperature. How do we measure heat accumulation during a growing season? For that, we use growing degree days, which is a climate index. We will look at the average daily temperature, the highest plus the lowest, divided by 2 minus 50, from April to October. The result is the daily heat accumulation sufficient enough to induce plant growth. 50 degrees Fahrenheit present a biological zero. Below, many plants won't grow. Here's a map of Virginia showing areas with different growing degree days, seasonal accumulation. 1,800 to 2,500 growing degree days are required to ripen American varieties, some French hybrids, and cold climate vinifera varieties. More heat over 2,500 to 3,500 are required to adequately ripen many of the varieties and some French hybrids. Growing degree day system for a calculation of heat accumulation is a useful tool to match variety with a growing region, where that variety will express a full potential in terms of growth, developing, yielding, and fruit quality. Also, it can help predicting stages of vine annual development, since the plant growth is closely correlated to temperature. I mentioned earlier that the growth will intensify above 50 Fahrenheit. The optimum range is from 66 to 86 Fahrenheit, after which will start to decline. Frost can occur in spring and fall, when usually warm weather is in early spring promotes bud burst, followed by sudden drop in temperature, minus 32 Fahrenheit, or in very dry conditions, minus 26 Fahrenheit. Damage of shoots, leaves, flowers will occur. We call that spring frost damage. This freezing temperature never gets low enough to affect permanent structure. When the primary shoots are killed, which can happen in any stage of early shoot development, a few weeks later secondary shoots will develop, so the vine can survive. However, since growth and yielding potential on secondary shoots are smaller, the spring frost can significantly reduce yield. When sub-freezing temperature occurs in early fall, it can damage leaves in such a way to interrupt photosynthesis and sugar production, which results in unripe fruit. Moreover, perennial portions of the vine won't store sufficient amount of carbohydrates, which will affect vine resistance. to winter damage and reduce growth potential in the following spring. Cold winter temperature can severely damage and kill grapevines. Low winter temperature can cause damage too. Overwintering buds. See the photo injury to primary, secondary, and tertiary buds. Vascular tissue, xylem and phloem, of canes, cordons, and trunks, like shown on the picture of your right in the bottom. Or kill the vine, which is happening on the picture of your left, bottom left. High susceptibility to winter injury has been the primary limiting factor for growing vinifera in eastern North America. On this slide, one can see an estimate of how frequently regions of Virginia experienced a low temperature of -8 degrees Fahrenheit per decade between 1967 and 1996. The darkest zones are those that experience 3 or more occurrences of -8 Fahrenheit per decade. If vines were significantly damaged 3 or more times per decade, the potential of profitable grape production will be exceedingly limited. One injury event per decade, on the other hand, may be tolerable, depending on the performance in the other 9 years. Notice that the majority of the vineyard acreage in the state is located in areas that experience at least one critical core event every decade. It is important that the vineyard site and layout is thoroughly evaluated to minimize the threat of cold injury. In that regard, it is important to realize that this map shows a general occurrence of cold events. There will be specific sites within the color-coded areas that do not experience the generalized temperature occurrence for that zone. This is why we have to go beyond macroclimate assessment and look at the finer details. As shown in the map, during July, many Virginia sites have average maximum temperature above 86 Fahrenheit, especially those in the more humid regions of the Tidewater, which also have average minimum temperature about 64 Fahrenheit. What does it mean for the vine productivity in that region? It means that will not be as productive as it is if it were growing in the region with optimal temperature. Optimal temperature range during the final months of grape ripening is 68 to 77 Fahrenheit daytime and 59 to 68 Fahrenheit nighttime. This is the temperature range that promotes color development on red cultivars and favors sugar, acid balance, and pH. Elevation and topography can be used to moderate the negative effects of regional unsuitability for grape growing in terms of either low winter temperatures or high temperature during the ripening period. If grapevines are exposed to a mild drought period to verizon, that can slow down the vegetative growth and benefit ripening. Excessive precipitation from verizon to harvest is undesirable because it leads to berry splitting and bunch rot. Varieties with tight cluster and thin skin are particularly sensitive to berry splitting, and growing in the regions with frequent rain prior to harvest can be extremely challenging. We know microclimate gives us a robust parameters and can only give us a general direction of where to look for the areas favorable for grapes. However, we need to use high resolution to scale down from a macro to meso perspective in order to pinpoint a good vineyard site within a state or a county, for example. A mesoclimate is the climate that at an intermediate geographic scale. It is what happens in a region on a smaller scale, such as downtown district, neighborhood, large park, farm, or wooded area. The mesoclimate has variables in altitude, topography, slope, land use, body of waters, air movement, cloud cover. For example, where the fog will burn off further away from a river's bank first and evaporates to the river's edge as it goes through the burning off process. It is influenced by the physical characteristics of the local area, like terrain features, vegetation cover, land use, body of waters, air movement, and cloud cover. Elevation is the height of a geographic location in regards to a fixed reference point. It can be absolute or relative. Elevation has a profound influence on minimum and maximum temperatures in a vineyard, particularly in hilly or mountainous terrain. Planting a vineyard on or near the highest point of any given location will promote better air circulation and water drainage. Air circulation is essentially in frost and freeze events. Cold air is heavier than warm air, so it settles in areas of low elevation. Water drainage is also important because standing water will limit the oxygen available to the vine roots system. Standing water limits their growth by killing small fibrous roots that provide the majority of water and nutrient uptake from the soil. Under radiational cooling conditions, with calm winds and clear skies, the earth loses heat to space and cools the adjacent layer of air. Remember that cool air is more dense and therefore heavier than warm air. Cold air drains downhill to areas of lower elevation. These areas are known as frost pockets. A frost pocket, such as the one pictured in the diagram, can cause winter injury when the vines are dormant or frost damage when shoots have emerged. Here you can see the importance of both absolute and relative elevation. Although the vineyard on the right side was within the optimum absolute elevation, its relative elevation or position to the trees is not ideal because the trees are located below the vineyard and will make a barrier for the cool air drainage. In reference to slope, we want to consider the degree and direction of it. The degree of a slope affects air movement. Higher degree, faster movement. Water drainage. No slope causes water to puddle or affect the level of erosion after rainstorms. The direction of the slope, whether the vineyard will face north, south, east, west, will determine the degree of the vineyard's exposure to sunlight and its exposure to prevailing winds. What is a desirable slope and aspect for a vineyard? It is a slight or moderate slope, the one that offers benefits for air and surface water drainage. The benefits of a vineyard on slope also come with serious safety and environmental concerns. Tractor safety is incredibly important on slopes. Tractor rollover, accurate spray application, and traction must be considered. Vineyard design and management must plan for and reduce the possibility of erosion. Slopes more than 15% introduce unique problems, but it can be useful if not road orientation is altered. Please take in consideration that some counties will not allow to cut down trees on slopes that are more than 15%. So talk with your county before planning for this. Aspect is the compass direction an inclined parcel land faces to. It is important since it affects physical parameters such as minimum and maximum temperature, heat accumulation, and relative humidity. Therefore, the vine phenology, which are the different life stages it goes through. For example, a variety that breaks bud early, like Chardonnay, therefore higher risk of spring frost on a site with southern aspect, which has an advanced bud break, greatly increases the probability of having problem with spring frost, which heavily reduces crop. Land use can be ranged from unsuitable urban areas and bodies of water to prime farmland. Current land use is not a direct indicator of vineyard site suitability, but it is important in terms of feasibility and establishing cost of a vineyard. For example, wood area can be used, but the site preparation is costly and requires a long period. Similarly, converting an old orchard to a vineyard. Proximity to sensitive areas like schools, buildings, bodies of water, and roads. The humid climate of Virginia increases the fungal disease pressure on grapes, as illustrated with the smaller image here of rooting fruit clusters. An important component of site selection is to seek a site with good sunlight exposure and adequate air movement that will help reduce fungal disease pressure and certain insect pests. Keeping vineyards 100 or more yards from wooded areas and tree lines is helpful for several reasons. It reduces shade and depth on the vines. It improves air movement, and it provides spatial separation of our grapevines from what may be potential alternative host for certain pathogens of grapevines. Wooded area is home for birds, deer, and other animals that like to feed on grapes. Microclimate is what exists within a few rows of a vineyard. It is in the microclimate that vineyardists have the most control of managing for the distinct flavors and aromas of wine grapes and the resulting wine. This is the reason why we are continually reading about this particular climate over all the others, terroir. In this picture, soil types visible crisscross the vineyards in patterns of red and gray, and pockets of fog linger in certain areas for hours, but not in others. In essence, each tiny alcove of different soil, humidity, and temperature is a microclimate. Weakest link in a soil testing program. Soil testing is used for vineyards to evaluate the chemical status of soil before and after planting. A soil test before planting can determine if there are any nutrient deficiency or toxicities that may affect the growth of young vines. We recommend to take soil samples before planting and 4 or 5 years after planting, or when there is a suspected problem. Divide fields into uniform areas: soil type, slope, crop history, previous lime fertilizer or manure application. About 10 acres for a single sample, less than 2 to 3 acres or on uneven land. Collect 15 to 20 soil cores per sample, random. We recommend zigzag patterns across the field. Take samples at 2 different depths, one from 0 to 8 and the second from 8 to 16. Thoroughly mix each sample in a plastic container. Submit about 1 pint of composite sample to the testing lab. If soil is wet, air dry. However, we do not recommend to take soil samples or work the soil when it is wet. For more information, please contact your extension agent. The factors to consider 1 year in advance are: begin planning the vineyard layout, correct any internal drainage problems, amend the soil as needed, choose the varieties, and order your vines. Planning the vineyard. The most sustainable method is to work on the future rows. If the site is on slopey ground where erosion may be a problem, it is best to apply an approved contact herbicide only to the row area where the vines are to be planted, leaving the raw minerals in sod. The killed sod can then be subsoiled, amended with fertilizers and lime, and cultivated to prepare a smooth planting bed. Adequate depth and drainage are important aspects on vineyard soils. Test pits 4 feet deep and 2 feet wide should be dug to determine the presence of hard pan or other root obstructing layers. These layers should be broken up by subsoiling with a chisel plow if possible. In areas of high rainfall, vines are often planted on a raised bed or ridge to improve surface drainage away from the plants. After subsoiling the rows, establish a ridge upon which the vines will be planted by throwing the soil from the edges of the row to the middle with a disc plow or other bed shaping equipment. This ridge should be 8 to 12 inches high and 2 to 4 feet wide. Amend the soil based on test results recommendation and protect the soil on the row by using cover crops. For further information, contact your extension agent. Based on the features of your plot, choose the varieties that can be grown in the most sustainable way, environmental, economically, and socially. Please visit the Virginia Cooperative Extension Wine Grapes website, where you will find research programs, publications, facilities, and resources, as well as the Viticulture Extension resources, where you can sign up for newsletters and blogs. The Grape Exchange website offers a guide to the different grape varieties and suppliers. For more information, please contact your extension agent. Conclusions. Site selection should consider the hazards at the macro as well as mesoscale level. Elevation is the most important feature a vineyard must have in the Mid-Atlantic region. It impacts length of growing season and frequency of low temperature extremes. Remember, we attempt to minimize risk. Be critical and selective with a potential vineyard site. And very important, how much does it cost to establish an acre vineyard? Between $15,000 and $20,000. This concludes the presentation. Thank you for your attention.